Okay, I guess we're back for round two here. So we're going to break this up into two sections. The hands-on, we have a brief and relatively simplistic hands-on just to get you the chance to try using PySpark. We have a reservation set up for that, and I'll show you the instructions. They're also in the Moodle for connecting to that, to Bridges 2, and to using the PySpark binary. And the goal here is just to work through some simple examples and get you some familiarity with working with a basic data set. In this case, it's the complete works of Shakespeare. And we are going to do our a brief coffee break at 3 o'clock, and then when we come back at 3:15, we'll do the MNIST hands-on, and we have a different reservation for the GPU for that. So without further ado, let's take a look here real quickly. So in order to connect to to Bridges 2 and to be able to use PySpark, the commands are right here. We're going to run interact. The N7, actually, I meant to take that out and I forgot. You don't need
recording
that,
in progress,
but you can use it. And that's going to give you more room if you want to do something that uses more memory. It's really not necessary for what we're doing here. That's going to give you seven cores, -R, and then big RM 6 July 11. Now, if you're copying out of the slides, you always have to be aware of the Microsoft change to the double dashes. So you probably want to copy out of the commands for, what do I call that file? Setup commands for hands-on if you want to just copy and paste, or you could just type it. But since I'll be going away from this slide, you're going to want to refer back to this if you need to. Once you're on a prompt on Bridges 2, on whatever node you end up on with your interact, you're going to type, you know what, I need to show you actually the other commands now that I'm thinking about it, because this does not include the important commands that are needed to copy the data files into place. So, okay, so this is the file that I'm talking about, and like I said, you can find this on the Moodle. You're going to run interact on Bridges 2 in order to get yourself an interactive job, and do it with that command there, and that'll set you up with a job inside the reservation. Then you're going to set up your environment first by copying the training folder into your home directory. Run that command from your home directory. And then CD into the Big Data Shakespeare directory. A lot of the work we're doing today is just so much simpler. If you don't have to do any hard paths, you can just be in the directory and find all the files you need. Then module load Spark and run PySpark. And you're going to get a Python shell. It's going to spit out a lot of information about the Python setup and tell you that it's set up a Spark context for you. And when it returns the 3 greater than sign prompt, then you're going to be ready to go. So I'll give everyone a minute to get set up. Questions? Bigger, yes, I think so. Okay, that may be, okay, that could be a couple of different things. Give me a moment. It's easier when I'm not trying to lecture and fix Bridges problems. No, I mean, there should be enough for 40 people to do it simultaneously with 7 nodes, or seven cores, excuse me. Pardon me? Oh, sorry, the commands you should do should be up to the PySpark. The rest is for later this afternoon. Yeah, so all the commands up to PySpark. Assuming you don't get an error when you try to do an interact. Has anyone successfully started an interact job? Okay, good. So a few accounts are having an issue, but I am having an issue too, so hold on. Thank you. Okay. All right, we will move on and get started, and once we get to exercise time, I'll come and individually help the people who might have Bridges 2 specific issues, but getting started with this shouldn't take too long. So let's assume that we've moved through these steps here. And again, remember, you can easily find this for yourself on the Moodle if I take this off the screen like I'm going to in a moment. But these are the commands. We're going to copy the training big data folder, the whole thing over recursively. We're going to CD to the Shakespeare directory, and then module load Spark, and then finally PySpark, which we will run on our interact node. Okay, so data analytics and Shakespeare, two great tastes that go great together. whether determining legitimacy of his authorship, maybe it was Marlowe, or if Othello is a comedy, there's been some research into that, or which words make Macbeth so creepy. There's a lot of research that's actually been done that focuses on Shakespeare's text, and today we're going to dive into here using a text file that contains all of his works. So, we have the complete works of Shakespeare, and we grabbed it off of Gutenberg, and it's easy to acquire for yourself, but we provided it for you here. And so we've got a copy of the instructions here, and the exercises are really, like I said, they're pretty straightforward. We're going to do just a simple, first a line count, just to get us started. And using the, you may have to refer back to the PySpark slides in order to find the commands that will, that let you do this using, using the PySpark commands. Then we're going to get a count of the total number of words. And again, that split command is going to be important there. You're going to want to look up how to do that in Python if you're not familiar with that already. Then count the unique words, and then we're going to have a slightly more advanced things where we're going to count the occurrence of each word, and then show the top 5 most frequent words. So take a crack at that, and let me know if you get stuck somewhere. And let me know also if you find that you are finished very quickly too, so that I know that we need to move on a little bit. But this is the exercise, and go ahead and have a look at it. If you are interested in more work with PySpark, since we knew that time was limited today, we did not add too much, but there are a few example data sets in here, including the 5,000 points one that we did the clustering exercise on, and there's also some great video that I know John Urbanek has put out about the recommender system, which we've done in previous years. But since we're going to be moving on to TensorFlow, we're going to spend a little less time here. So without further ado, let me know if you have any questions. Okay, it's time, 10 minutes to 3, and time marches on, so I'm going to go over some answers to these. I know that you probably could have used some more time, and I apologize we couldn't make it last longer, but we'll do what we can here. So, some answers to the first few, which I hope were not too terribly challenging. First, we get our RDD into the text file, it's RDD. And we do just a simple dot count to get the number of lines, and we get 124,000 or so. Here, this one was slightly more complicated. I know that it tripped a few people up. So in order to get the words into an RDD individually, we need to split up the lines. And to do that, we use this split command, and we use that lambda that we were talking about earlier in a flat map. So you may recall from our discussion that if you do a map, you're going to get a one-to-one relationship between the input and the output, but if you want to get more outputs, you use the flat map command, and this allows you to expand the size of your samples there, and we split them. And in that way, we get one element in the RDD for each word. Okay, and then if we want to count how many words there were, we just do a count on that distinct RDD, and we get around a little under 68,000. So, did you get a pair RDD of sorted word count pairs? Okay, so why not use just the RDD count by value? So this was my first inclination when I looked at this too. And it is something that you have to think about for just a moment. If you use transformations, then you don't have to do any actual work on the server. You're just doing a logical operation, which won't be implemented until it needs to be, and you're therefore deferring a lot of work and possibly will do actions later that make some portion of it unnecessary, and it'll be basically erased out of the directed graph that PySpark creates internally. If you use the count by value, then you're going to get this massive Python dictionary back in your console, which with 67,000 entries isn't that much, but if you were working with terabytes, petabytes of data, then all of a sudden, having this pushed into your console is probably not what you want. So if you do this using the transformations first until you're ready to do operations like count on your very large data set, you're going to find your performance is a lot better. So if it's truly big data, you want to remain in an RDD as long as possible. Okay, some harder answers here. One of the things that we can do here is we can just map each item if we want to count them. Remember that when we do our reduce operations, we want to have commutative additions. So what we're going to do is we're going to create an RDD that is a copy of each word and then the number 1. Okay? And then we have here the 1, project 1, Gutenberg 1, ebook 1, etc. Then we're going to take the key value pair and we're going to reverse it. We're going to do, or sorry, we're going to reduce it. I'm sorry, we're going to reduce it by adding all of these ones together for by key. So all the thes get added together. So 1 plus 1 plus 1 plus 1 plus 1 plus 1 until we have a list of them. So the word fawn appears 11 times. Considered only once, apparently. Fame for 3 times, etc. Mustachio, amazingly, only once. I wish that was used more often. Okay, and here we're going to flip the RDDs. So we have the number as the key and the word as the value. Okay, this operation with the lambda just creates a new RDD with the values reversed so that the key is in the first slot and the value is in the second slot. And then we take our flipped RDD and we sort them and we take a certain number of them and we only need to calculate a relatively small number in order to get this. So we get the top 5 of them. The appears around 23,000 times, et cetera, et cetera. So those are the kinds of ways that you want to start thinking when you want to do this kind of data science and you want to start trying to work with very large data sets and minimize the degree to which you actually tax the systems that they're on because you're going to minimize the time it takes for you to do anything. You'll get to the next stage and identify problems with what you're doing much faster. So, okay, forgot that we animated those. So. Okay, and the final note here is that one of the ways that PySpark works that turns out to be pretty convenient when you're doing a lot of this kind of work is you can just string these functions together. Honestly, and I usually say this, and I think I forgot to mention it this morning, but when you look at that collection of like map, reduce, etc., to me it looks very much like piped shell commands, where you're saying, you know, cat space, pipe into grep, pipe into sort, pipe into unique, etc. And really, this works in a very similar way, where you can have these filters really, you know, drill down to the very particular thing that you want, and you don't have to split it up into a bunch of lines if this is more readable for you. So, okay, with that, we're gonna call it the end of this section. Oh, I did want to mention that there are some more things that you can do if you'd like further work in this realm, and in particular, I really wanted to mention stemming. So if you have go and going, for instance, or other words that are similar versions of the same word, you could think for a second, and it's pretty hard to actually find simple rules to eliminate all of those, but someone has actually done all the work for you. There's the Natural Language Toolkit, and there's a stemming library that you can use so that you can identify words that that are all different versions of the same word. When you're trying to do actual analysis like this, that's one of the starting points where you're going to want to try to find ways to actually combine your words. So there's a lot more that you can do if you want to look into the ways that that PySpark can be used to do language analysis, and this is a good starting point. So with that, we will move to our coffee break, and we'll reconvene at 3:15, and we'll get started right away on the deep learning exercise. So thank you, and let me know if you have any questions.